Multiple clients can access the same entity object using multiple instances in Jakarta Enterprise Bean, so EJB. Here you can see multiple clients access the same entity object using multiple instances. When writing the entity bean business methods, bean provider does not have to worry about concurrent access from the multiple transaction. The bean provider may assume that the container will ensure appropriate synchronization for entity objects that are accessed concurrently from multiple transactions. The container typically uses one of the following implementation strategies to achieve proper synchronization. These strategies are illustrative, not prescriptive. So we are here considering one implementation. The container activates multiple instances of the entity bean, one for each transaction in which the entity object is being accessed. The transaction synchronization is performed by the underlying database during the accessor method calls performed by the business methods. The EJB timeout method and EJB load, EJB create method, EJB store, and EJB remove methods. The commit time options B and C in commit options applied to this type of container. So commit options computation B is container caches a ready instance between the transaction. C is container does not cache a ready instance between transactions. With this strategy, the type of lock required by EJB load and EJB get accessor method is if the lazy loading cache management strategy is used, leads to trade-off. If the EJB load or the accessor method requires exclusive lock on the instances stays in the database, the throughput of the read-only transaction could be impacted. If the EJB load or the accessor method requires a shared lock and the instance is updated, then either EJB store or the set accessor method will need to promote the lock to an exclusive lock, which may cause a deadlock if it happens concurrently under multiple transactions. So if the container uses an optimistic cache concurrency control strategy, the container will need to validate the state of the cache against the database at the transaction commit, which may result in a rollback of the transaction. Here you can see client 1 and client 2 are connected to entity object account 100. Here the client 1 is connected to entity object account 100 via TX1. Client 2 is connected to entity object account 100 via TX2. Entity object account 100 connected to the container. So here you can see the enterprise bean instances. Entity object account 100 is connected to the entity object account 100 in TX1 here, and account 100 TX1 is connected to the account 100 to the database. The account 100 is inside the database, and here entity object account 100 is connected to the account 100 in TX2 here. Account 100 in TX2 is connected to the database and account 100 is in the database here. So enterprise bean instances are in the container here. Now this is the end of my presentation. Thank you very much for watching it.